Okay, now we do this area of parallelogram. So you see, let's say this is a parallelogram ABCD. How do you find the area of parallelogram? AB means the length of AB, the length, okay? And then AD means the length of AD. This is the length of AD, the length of AB. So here this is not vector. I just revise with you what you have learned in your lower form. I think form 1 or form 2 you come across this. So this is not vector, this is just a normal line. It's the length AB and AD. Form 2, I think you learned this, form 1. So area of parallelogram ABCD, this is the base times the height. And then the base is AB, the height is H. So how do you find H? You look at the triangle here, sine theta is H over AD. Therefore, the H is this, so we substitute the height H here, substitute inside. You have the length AB, the length, AB is the length. How long is AB? Multiplied by AD and then sine theta. That is the area of the parallelogram ABCD. This one you learn in form 2, form 1, okay? This one you learn in form 1, not form 6, form 1. Okay, when you first exposed to parallelogram. Okay, now, so, okay, area of parallelogram, that is the length, okay? I always remind you this is the length AB, and then the length AD multiply sine theta, okay? The length. Okay, this one form 1. Okay, now we are going to use vector way of solving. Now I show you. When I put an arrow like this one has become vector. This one has become vector. Why I want to use vector? Because this one is only 2-dimensional. This one can be 3-dimensional because they can come out from the board. Like I showed you the other day. Okay, we are going to do 3-dimensional. Okay, so this vector, this is a vector. Vector AB, vector AD. So you see the magnitude of vector AB, this is the length of AB, so I can write like this, correct or not? Then the magnitude of vector AD in form 1 we just write is AD, isn't it? So form 1 we write AD, that means now if vector is magnitude of vector AD, the length AD and the magnitude here is same. The length AB and the magnitude here should be the same. Okay, so here is form 1. This one now we are going to do vector. Okay, so settle with this now. And then here, if I cross AB cross AD, according to our formula is magnitude of AB, magnitude of AD, sine theta, and then you have the normal. Is it? When you cross two vector, you get the vector which is perpendicular to these two, and perpendicular to these two, we call it the normal of this and this. Just like I always draw the what we call the tetrahedron. Okay, so you have one vector here, the tetrahedron, like that. Okay, then this is the normal. Okay, that is how we get. Okay, that is a normal, and this one, the magnitude is 1. This is the unit vector, just like the I, J, K, and this N is. So you see, when I take the magnitude, because this is a vector, this one also vector. So this is a vector, this two also vector, but this two is not vector. This is the length. This is the length of AB, length of AB. How long is AB and AD? And sine theta is not a vector because sine theta is an angle. Angle has no direction. And then the length AB also no direction, only magnitude. So these two magnitude is the length. Okay, so when I take module, I find the magnitude. Here also I find the magnitude, but this one is not vector, so no magnitude. This magnitude only, magnitude no direction. This one also is a magnitude only, no direction. This one is a vector, so magnitude of this vector and magnitude of this vector, but the magnitude of this vector is 1. Okay, that's why you get, because this is the magnitude is 1, that's why we don't write this is 1, so don't need. So the magnitude of this equal to this, so you can see that you have this. And then from just now, area of a parallelogram ABCD is AB, AD sine theta, is it? And I told you already they are the same. Therefore, meaning this one same, these two same, isn't it? They are the same. Okay, these two, they are the same. So from here I can conclude that area of parallelogram is the same as you cross AB, vector AB with AD, and then you find the magnitude. You cross them. That means you find the vector which is perpendicular to them, normal to them, and then you find the magnitude. That is the area of the parallelogram. Okay, so that's the area. So area of parallelogram is ABCD. Of ABCD is AB cross AD. Then you find the area. Okay, so remember this one. This is the length. Magnitude means the length AB. This is in vector form, and this one is we write it in form 1. Form 1 we write like this. Okay, so if the area of parallelogram is this one, so what is the area of a triangle? So you see, if the area of parallelogram is this one cross this one, the magnitude, okay, you must take the magnitude, then the area of triangle will be half of it. That means the area of triangle is half of the parallelogram. So the area of triangle is half. Okay.